Okay, so we're going to continue with energy. Remember, you should have notes open in your notebook. You can continue on the page we were last using for our energy notes, or you can start a new page. It is up to you. We're going to start off with different energy forms. So I've already got a lot of this typed out, and as I highlighted, that's what I want you to be writing down. So energy forms, if we look at this image here, you can see different forms of energy that we've already kind of talked about. We've talked about nuclear energy, electrical energy, heat energy, sound energy, wind energy, all these different types of energy. And what I want you to write down is that energy is present wherever there are moving objects, whether those objects are large or small, that's when energy is present. So here are some different forms of energy. We've got gravitational energy, and just to make sure we understand gravity, anything that goes up must come down. That's why when you throw a ball up into the air, it comes right back down. The force of gravity acting on Earth. So there's gravitational energy, there's magnetic energy, thinking of a magnet, and there's light energy. So what I want you to write down are these three forms of energy. Include. All right. So if you look at this picture, if you notice the rock here, point A, and then the rock here labeled B, and it's asking you, when you are looking at an object, how can you tell how much, if any, energy it has? So looking at these two rocks, how can you tell how much energy they each have? And you don't have to write down the question, but I do want you to answer that in your notebook before moving on to more notes. So from these pictures here, talking about amount of energy or how much energy an object has, this tells us that an object with more energy moves faster. So if you're looking at these two pictures, it's obvious the car that moves faster and has more energy. You've got these race cars right here. And then if you look at these two pictures, it tells us an object with more energy is higher in the air. So which has more energy, the balloon or the ball? And I want you to write all of this down. And for the questions that ask you which has more energy, I want you to tell me which car has more energy and whether the balloon or the ball has more energy. So continuing amount of energy, if we looked at a compressed spring, that's what this picture is right here. A compressed spring means it's squeezed together. This spring has more energy than an untouched spring. So which of the above is compressed? Well, it's this one right here, and it contains more energy than the uncompressed springs. So remember that any moving object has kinetic energy, and the faster that an object moves, the more kinetic energy it has. So once again, we see these super fast race cars. Write all of this down about kinetic energy. I want you to go ahead and add this on. The faster an object is moving, the more energy it has. So like this airplane, an object that is moving faster can travel a farther distance before stopping. And that's a pretty obvious when it asks us why. It's because the object is moving faster, and because it's moving faster, it can travel a further distance because of all the energy it has. Because we know that a faster object has more energy than, say, a slower object. And finally, looking at potential energy. Potential energy is determined by distance. So remember, potential energy is when an object is not yet in motion, but has the potential to move. So potential energy determined by distance. So think about that example of the ball at the top of a hill. It hasn't started rolling yet, but think about the higher of a hill it's on, the more potential energy it has, because once that ball starts moving, the faster kinetic speed it's going to have. So I should write down that the higher in the air an object is, the more potential energy it will have. And if we look at this picture, I think it's a picture of Alice in Wonderland. But as an object gets closer to the ground, it has less potential energy. So once again, think of a ball on a hill not as high. The potential energy is less because once that ball starts moving, it won't be able to pick up quite as much speed as the ball at the top of a taller hill. So an object gets closer to the ground, the less energy it will have. And that's where we're going to stop today.